position function or ST. Then S prime is the velocity of this horizontal particle, and A is called the acceleration. Acceleration. How to spell acceleration? And J means jerk of this particle, moving particle. Okay. But usually for a straight line or plane motion, we use the first three functions. If a curve is moving on space, then maybe we use this. Because the second derivative can be used to describe how curved, curvature of this curve. And third derivative can be used to describe torsion, like a spring cannot put it on the plane. Curvature means curve. But torsion means cannot put this on the plane. Maybe like a spring. Cannot put this curve on a plane with the three-dimensional objects. Okay, anyway, they are all important. In Chinese, in Mandarin, 位置、速度、加速度、变加速度。For this absolute value function, where is it differentiable? Take a look at the graph of the function. We already know this function is continuous everywhere. But now we want study its differentiability. If x is positive, this is squared and cubed. Here, Oh, yes, 2 here. Oh, yes. Should be 3. Yes, you're right. Because, oh, no. 2, 2. Squared. Good. You are very careful. It's a good thing. This is a good thing. Well, if x is positive, then by definition, so for any positive number x, if h approaches 0, we can choose h is non-large, for example, less than maybe half x. On this interval, this number will be positive, so the absolute value of x plus h is x plus h. So by the property of the absolute value, we know this is x plus h and this is x. Then x and x are cancelled, h and h is also cancelled. Meaning the slope here, slope of the curve of the graph is 1. Of course, because this is part of straight line. The slope is 1. Now, if x is negative, for example here, again, we choose h not too large, such that maybe a half of this length. Then this number will be negative. The negative of a negative number is positive. But this time, minus h over h is minus 1. Since this portion is a part of a straight line, the slope at this number or to this curve is, of course, minus 1, the slope of that straight line. Finally, at 0, since the absolute value of x equals x, if x is not negative, minus x is negative. So around the origin, or 0, the formula for defining this function are different. So we use a one-sided element, two one-sided element to evaluate this one. So this is almost the same as in this case. Or you can say the right derivative of the function at 0 is 1. The right derivative of the function at 0. Now, h is minus, is negative. Since these two limits are different, this not x means not differentiable thing. So conclusion, we conclude this. F is differentiable at every non-zero number. Every non-zero number. And F is not differentiable at 0. Because F prime of 0 does not exist. So I think this textbook is quite good. And this example also shows the convergence of differentiability implies continuity fail or fails. Fail. Yes, this is true. Differentiability implies continuity. The converse of this statement is not true because we may consider the absolute value function. This function is continuous at the origin, not differentiable at 0. Continuous, but not differentiable. Okay. So differentiability, differentiable means smooth. The absolute value function is continuous here, but there is a corner here, not smooth. Okay, there's a right angle here, the corner. So this leads to the next question. What question? How can a function fail to be differentiable? How can a function fail? Means not differentiable. Just like when we talk about continuity, how can a function which is not continuous at some position, for example, have a jump or removable or have an infinite discontinuity, right? But similarly, we can ask if a function is not differentiable at some point, the behavior will be like what? Our text will give some examples. Like this. Here the right derivative exists. The left derivative exists, but they are not the same. In this case, we call there is a corner here. The corner here. Because differentiability always implies continuity. If f is not continuous here, then definitely x is not differentiable here. And finally, even smooth, but the tangent is a vertical straight line. Smooth, but the tangent won't hold. Vertical line without slope. Okay. Maybe vertical tangent seems not so precise. Precisely, the author gave a definition here. Okay. The author gave a definition here. The straight line, the vertical line, x equals a is a vertical tangent. For example, here. This is x equals a, the vertical line. This is y equals f of x. The slope, positive, 0, negative, oh, negative infinity. Positive, 0, negative, oh, goes to negative infinity. So this, this straight line is a vertical tangent. Also, by this definition, this is also a vertical tangent. Because here slope is positive, 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 all. Positive infinity. Negative, 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 negative infinity. Also a vertical tangent. Of course, some textbook call this case cusp. I don't know whether this spelling is right or wrong. Cusp means cusp. Okay, anyway, in this textbook, both this one and this one are with vertical tangent, okay? By definition. Takes a short break, thanks.